Continuing back, example 6, find the integral 0 to 1 4 plus 3x squared. If you do not understand this example, it's okay, just have a look at it. Like derivatives, after doing several problems, you'll get a feel for integration problems, okay? This is called definite integral. First, split along the plus. So integral of this is plus of integrals. So if you have plus or minus along in your expressions, split along the pluses and minuses. This is a constant. All right. The constant integral is easy. Okay. It is that constant comes out upper limit minus lower limit. All right. Whereas here, this constant is being multiplied to a function, to an expression in x. So get that constant out. Integral x squared. Okay. Integral x squared 0 to 1. You can use your limit definition and figure out it is going to be 1/3. Okay. So that is 1/3 there, 3 here, 4 plus 1, 5. Okay. This is something you may have forgotten, but you can do this again, or as of now, accept this, and then let's do a few examples later and you will figure it out. Here is a property. If this is an important property, by the way. If I'm looking for integral from a to c and then c to b, it is same as going from a to b because it's an entire interval. A to b, c is somewhere in between. So area under a curve from a to a number c and then c to a number b is same as saying area from a to b. Okay, here is the picture. A is here, b is here, c is somewhere here. Area under the entire curve can be split once here, here. Sum of these two is the entire area. All right, that's all we are saying. Integral from a to c plus integral c to b is integral a to b. All right, this is an important result. Comparison. If f is greater or equals 0, that is my function lies always above my x-axis, then the area will be greater or equals 0. All right. If f is greater or equals g, that is the curve of f is above the curve of g, then the area under f will be bigger or equal area under g. If f is between two numbers, then area under f will be between these two numbers. All right. Let's see a few explanations. If f is greater or equals 0, what does that mean? Your curve is above the x-axis. So area a to b fx dx represents area under the graph of f. So by geometric interpretation, it simply means that areas are positive. You see, because if your curve had some parts below the x-axis, you would have to subtract that. That's where you get the negative subtraction. But if you don't have to subtract anything, you're all above x-axis, then your area is always greater or equals 0. Well, property 7 says f is bigger equals g. So it is a bigger function, higher function. So of course area under that, its curve will be greater. Okay. Properties. All right, that's that. Now this is an important one. This is the one where f is between constant function m and constant function capital M. Okay. So that was an important case I informed you. If your function is between two values, little m and capital M, then what happens to the area under f? Okay, so that's the picture. Your f is between little m and capital M. Well, area under the curve of f, you see this entire area is bigger than the area of this thin rectangle and smaller than this fat rectangle, right? Because this area contains the small sliver and is contained in this big rectangle. Well, what is this big rectangle? That's area of capital M. What is this small rectangle? That's area under little m. So obviously you're going to get area under the graph of f is greater than or equal to area of the rectangle with height m less than area of the rectangle with height capital M. Okay, this property is very useful when you're this property is very useful when you don't know the actual value of this integral. Sometimes these integrals are difficult to find, but you can estimate, oh, that's a bigger area, you can estimate that, you can estimate that, and so on. All right. So this completes the entire lecture slides for section 4.2, and the next videos will cover problems from web work on this section. Until then, bye.